Alright, so for today's video, we're going to continue with factoring. So in the last lesson, you learned about how to factor out a GCF, which basically means that you're going to undo any distributive property that you did. So you're pulling out the number that you would have multiplied in initially. So we're going to learn how to factor today, which again is to undo multiplication. And we're going to factor what we call the difference of squares. These are patterns that we can bring our multiplication back into two parentheses. So let's just kind of review quickly. So if we are talking about finding the product, so finding the product means that we're going to multiply. So I'm going to set up my box and I have x and -3, x and +3. So this is going to be x squared, -3x, 3x, and -9. Now what's happening here is these two are going to cancel each other out. So we're left with x squared minus 9. Now this is important because we're going to start talking about perfect squares. So perfect squares are numbers that as I square that number, what is the product? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And we can keep going on with that pattern. Now, if I were to do the opposite of that, and I did the square root, so if I take the square root of 1, that's going to give me 1. So taking the square root undoes squaring. So the square root of 4 is going to give me 2. The square root of 9 is going to give me 3. The square root of 16 is going to give me 4. Square root of 25 is going to give me 5. So these are patterns that you need to recognize. So just like for the next example, I would do my box again, and I have 2x and 5y, 2x and -5y. So we're going to have this is going to be 4x squared. Then we're going to have 2x, 10xy. We have -10xy, and then we have -25y squared. So again, these two are going to cancel each other, and I'm left with 4x squared minus 25y squared. Now, the pattern that I want you guys to see is that these are almost identical. The only thing that is different is the plus and the minus. Same thing here. These are identical besides the plus and the minus. These are the types of answers or the types of factoring polynomials that we're going to get when we undo our multiplication. So, few things to remember when we have difference of squares. So difference of squares is just a shortcut method to factor. Now, the key here is there's two key words. We have difference, which is going to mean subtraction, and we have squares, which means we have to have perfect squares. If we don't have subtraction and we don't have perfect squares, then we can't do this method. This only works because it's a shortcut method if we have subtraction and perfect squares. Now, the other thing is you're going to have to check for a GCF first. You always are going to check for a GCF first, no matter what factoring method you come across. Now, the other thing is this does not work if you have the sum of squares. This only works with the difference of squares. Now, the other thing is exponents, in order to be a perfect square, exponents must be even. Even exponents are perfect square exponents. So, when I'm looking at this is how I look at it. So, I look at my first term. My first term is x squared. That's the even exponent. That is a perfect square. My second term is 25. 25 is a perfect square because it's 5 squared. And I have subtraction in the middle. So I can break this down into two parentheses. So I'm going to write two parentheses, 1 plus, 1 minus. Now, I'm going to take the square root of x squared, which is just going to be x and x. And I'm going to put those in the same spot that the x squared was in originally. I'm also going to take the square root of 25, which is going to be 5 and 5. Okay? You can see this same pattern. I have subtraction, I have x squared, and I have 9. And because of that, when you took the square root, we got x and x. and then the square root of 9 is 3 and 3. But the key here is that there's always a plus and there's always a minus. If you don't have a plus and a minus, your answer is wrong. Now, for the next problem, this example, there is a GCF. These both have a 3 in common. So they pulled this GCF out, and it left me with this difference of squares. So this difference of squares can now be factored into a plus and a minus, with 25 and square root of 25 being 5. So we're going to do several examples, and we're going to look through and talk more about this. So for the first example A, I have x squared minus 64. Okay, I have subtraction. I have x squared, that's even, and 64 is a perfect square. There's no GCF. So I don't need to do anything because there's no GCF for the first one, but I am going to do my difference of squares. So my difference of squares, I need a plus and a minus. I'm going to take the square root of x squared, which is just going to be x and x. And then I'm going to take the square root of 64, which is going to be 8 and 8. Now, if I were to multiply this back out, it would give me x squared minus 64. So again, we're undoing multiplication. All right, so look at the next example. So I have a difference. I have 16, which is perfect square, and h squared is a perfect square. 9 is a perfect square, and a squared is a perfect square. So because these are all perfect squares, the next thing I'm going to look at is their GCF. Well, I have h squared and a squared, so the exponents don't have perfect squares. And then I have 16 and 9. Those don't have a GCF either. So I can go ahead and set up my two parentheses, one plus, one minus. So the square root of 16 is 4, and then the square root of h is h. So this is going to be 4h on both of them. The square root of 9a squared, so the square root of 9 is going to be 3. And then a squared is a. So for the next one, we have the difference. We have subtraction. 121 is a perfect square. 4b squared is a perfect square. And I do not have a GCF. They do not have anything in common. So I'm going to do my parentheses. My difference of squares is 1 plus, 1 minus. Square root of 121, that's going to give me 11. And remember, they have to go in the same spot as the original. And then I have the square root of 4b squared, so that's going to be 2b and 2b. All right, so for the next one. So the next one I have subtraction, but then I noticed I have an odd exponent, and these are not perfect squares. So when I look at this, the first thing I'm going to notice is that I could potentially have a GCF, and I do have a GCF. These are both divisible by 3 and g. So I'm going to take 3g out of my problem. And we need to talk about what's left over. So 27 divided by 3 is going to give me 9. I had 3 g's, but I took one out. So I had 3 g's, but I took one out. So that's going to leave me with g squared minus. So then 3 divided by 3. That's going to give me 1. And then I had 1g, but I took it out with my GCF. So that leaves me with this problem. Now, 1 is a perfect square. So 1 is a perfect square, and 9g squared is a perfect square. So we can actually factor this further. So I'm going to write two parentheses, but don't forget to include your GCF in the original problem. So I'm going to take the square root of 9g squared, which is going to be 3g, and then the square root of 1 is still going to be 1. So just to make sure we understand here. So the first thing I did is I took out my GCF 3g, and that left me with 9g squared minus 1. All right, so we have 9g squared minus 1. And then I broke 9g squared minus 1 down into 2 additional parentheses because I had the difference of squares. Okay. So you always check for a GCF, and then you check to see if you have the difference of squares and you can break it down further. All right, so for the next one, I have the subtraction. I have b to the 4th. Now that's an even exponent, so that's a difference of squares, and so is 16. So 2 parentheses plus a minus. All right, so b to the 4th. If I take the square root of b to the 4th, you're basically dividing it in half. So that's going to be b squared and b squared. B to the 4th, we're going to break it down to b squared and b squared. The square root of 16 is going to be 4 and 4. Now, this is where we're going to look even further. And we should be able to identify that this is also a difference of squares. So we can actually break this down even further. So I can't break down the b squared minus 4 because that's a sum. We can't do sum. But we have the difference again. B squared is a perfect squared, and so is 4. So I'm going to write 2 more parentheses. So this is going to be a plus and a minus. So this is b and b. This is 2 and 2. Because the square root of b squared is b. The square root of 4 is 2 and 2. So we broke b squared minus 4 down even further to factor that into 3 separate parentheses. All right, so looking at the next example, so we have 625 and we have x to the 4th. So when I look at this example, I have the subtraction, so we still have that. Oh, so we are going to change that. So we still have subtraction. 625. Now, if you take the square root of 625, it is 25. So that is a perfect square because it's 25 squared. So 25 squared equals 625. And then x to the 4th is even. So we're going to do 2 parentheses plus and a minus. All right, so we have 25x squared because the square root of 625 is 25. So 25 and another x squared. And again, I have another difference of squares that I can reduce this problem down. So I'm actually going to write it down here. So I still have 25 plus x squared, but I'm going to break that down into 2 more parentheses. Okay, so I have a plus and a minus. So the square root of 25 is going to be 5 and 5. The square root of x squared is going to be x and x. So in breaking that down, I've now created 3 parentheses or 3 factors of that problem. All right, so the next example, I'm going to look at this problem. I see that I have a subtraction. I have 16y to the 4th is a perfect square, and so is 1. And we have no GCF, so we're going to do plus and minus. So the square root of 16 is 4y squared, 4y squared. And the square root of 1 is 1 and 1. Again, when I look at this problem, I have another difference of squares that I can break down further. So we're not going to mess with the addition sign because we didn't say sum of squares is the difference of squares. So we're going to break that down with a plus and a minus. So the square root of 4y squared is going to be 2y and 2y. And the square root of 1 is 1 and 1. So we broke that down even further. All right, so for this last one, we have an odd exponent. We do have subtraction, so we can't do anything right now. But what I can do is I could check for a GCF. So that GCF, when I look at this problem, they both have a 5 in common, and they both have an x in common. So my GCF is going to be 5x. All right, so what does that leave me with? Well, 5 divided by 5 is going to be 5, or excuse me, is going to be 1. And I had 5 x's, but I took one out. So 5 x's, I took one out. That's going to leave me with 4. And then for the next problem, I have 45. So 45 divided by 5, that's going to be 9. I had 1 x, and I took one out, so there's no x's left here. So no x's left. All right, so in doing that, I now have the difference of squares that I can reduce. But don't forget your GCF because it's still going to be part of the problem. All right, so the square root of 1x to the 4th is going to be x squared, or 1x squared. And then the square root of 9 is going to be 3. Now, do not make the mistake and think, oh, I can reduce that down. 3 is not a perfect square. So we are actually going to be done with this problem because we do not have any more differences of squares that we can factor out. All right, so remember, when you have perfect squares, you're going to reduce it. So there's always 2 things that you got to remember. You got to have a plus and you got to have a minus. And then this is going to be the square root of x squared and the square root of x squared. This is going to be the square root of y squared and the square root of y squared, which is going to reduce, so we still have our plus and our minus, to x and x, y and y.